Hello everyone. Today we will start with a new topic called friction. So friction is nothing new to us. We have already known what is friction, and we know that friction is something which opposes the motion, which opposes the tendency to move, which cause a moving body to a state of rest, right? Let's understand by an example, right? So let's say there is a ball, and if a person kicks this ball, and you know that the ball will go and stop at some point, right? So why did this ball stop? This ball stopped because during its journey, there is some force acting on it which is opposing its motion, and at this point of time, that force has caused this body to come to rest, right? So, that force is called friction, right? And friction occurs whenever there is a contact. Whenever there are two surfaces in contact, there exists a friction force, right? So let's understand again. So this is a surface one. On this surface there is a block kept, right? So there is a contact between this block and the surface, and there will be some atoms at the bottom of this block and atoms on the top of this surface, and there will be some kind of electromagnetic interactions. And based on these two electromagnetic interactions, there is a force generated which is called force of friction, right? Now we know that surface offers a normal reaction as well to this block in response to the gravity. So this surface is offering two types of forces. One is the normal reaction, other is the friction. We represent friction by small f, normal reaction is represented by capital N. So this surface is offering two different forces. One is the normal reaction, other is the friction, right? So we will understand what is friction and what is how the magnitude is given and all that. But as of now, let's understand that whenever there is a contact between two surfaces, there exists a opposing force called force of friction, whose direction is in the direction to oppose the tendency of motion of that object, right? Okay. Now this friction is classified into two different categories. One is kinetic friction, and other is static friction. So as the name suggests, whenever the two bodies are moving against each other, whenever there is a motion, whenever they are being rubbed against each other, there exists a kinetic friction between two bodies, right? Static frictions occurs whenever a body is at rest with respect to another. We will understand by an example on what is kinetic friction and how it is derived and what is static friction and everything. So let's start with the kinetic friction. Kinetic friction. So let's say there is a block placed on this surface, right? And the velocity of block is in this direction initially, right? Now this block is in motion with respect to this surface. There is a motion between two contact. This is the contact, and there is a motion. This is block is being rubbed against this surface. So there will exist a force of friction here, which will be kinetic friction. So the friction which is present during the motion is the kinetic friction whenever two surfaces are in motion against each other. So that kinetic friction will occur here at this surface, and it will, now we need to find what is the direction of that kinetic friction. So the tendency of that kinetic friction will be to oppose the motion of this body. So since this body has a tendency to move towards the right, the kinetic friction will exert toward the left, and hence it will oppose the motion of this block, right? So kinetic friction will occur towards the left, right? So by a general rule, we understand that kinetic friction always exerts against the direction of motion of a block with respect to the opposing surface, right? So let's say there are one surface, let's say we call it as A and another is B. So kinetic friction will always occur against the motion of A with respect to B. So the motion of A with respect to B is in the right direction. So kinetic friction on A will occur on the left direction, right? So let's understand by one more example here. Now let me draw one more diagram. So there is a block here A, and then there is a block here B, right? There are two blocks, and then this is the horizontal surface. So let's ignore this horizontal surface for now. Let's talk between these two blocks. So these two blocks are in contact, so there will exist a force of friction between them, right? Now let's say that block A is applied with a force F in the right direction. Block A is applied with a force F in the right direction. Now we need to understand what is the direction of friction which will occur on B, and again what is the direction of friction which will occur on A, because whenever there is a friction on B, there will be friction on A as well. Newton's third law, right? So as I said that there will exist a kinetic friction because we are talking about the blocks which are in motion with respect to each other. So there will exist a kinetic friction between them. Now, friction will always occur in a direction so that it opposes the motion. So friction will occur opposite to the relative motion of A with respect to B. And for B, it will always in the direction where it opposes the relative motion of B with respect to A. Right. Now let's understand that if A is given a force F in the right direction, you know the tendency of B will be to move towards the left. So B will get a pseudo force, right? Because system is moving with a force F in the right, B will get a pseudo force F in the left direction. So velocity of B with respect to A is in the left direction. Now the kinetic friction on B will be in such a direction that it opposes its velocity with respect to the opposing surface, which is A, right? So the kinetic friction on B will be in this particular direction, small f. And for A, you can say that for A it will be in this direction. So let me put it this as FA and FB, but FA will be equal to FB, Newton's third law, right? So now if you need to write the force equation for this, you know that force, this is pseudo force which is on the right, and frictional force which is on the right, and pseudo force on the left, right? So with this we understand what is the direction of a kinetic friction. So kinetic friction on a body, it is always opposite to the velocity of that body with respect to the opposing surface, right? With respect to the paired surface with respect to which we are calculating the friction. Now, on what factors does the friction depends, right? So the friction between these two blocks will depend on the roughness of that area. How rough is the surface between these two? It won't depend on how fast you're picking up block, right? It won't depend on the speed. It won't depend on the relative speed of A and B, right? So if I talk about relative speed of A and B, friction will not depend on the relative speed, right? And what about area? Even area. Friction will not depend on the area. So friction only depends on one thing, which is the roughness. So if surface is smooth, friction will be less. If surface is kind of rough, friction will be more. As simple as that. Right. Now, for example, let's say there is a surface, right? There is a surface, and then the block is kept horizontally like this on this surface, right? So if same block, if I keep this vertically, will the friction change? I said that the friction is not dependent on the cross-sectional area at all, right? So the friction which is occurring on this block will be same in both the alignments, right? So friction is independent on the area. It is always dependent on the property of the surface. It is independent of the area. It is independent of the velocity of the surfaces with respect to each other. Now let's talk about the magnitude of kinetic friction. How do we derive what is the magnitude of kinetic friction, right? So let's say this is the surface and there is a block placed, right? The surface will have mass m, there will be a gravity mg, there will be a normal, and there will be a friction depending on the motion. As of now, I've indicated towards the right. Okay, let's start again with the magnitude of kinetic friction. What is the magnitude of the kinetic friction which is occurring? So let's say this block of mass m is placed on the surface. The block has a gravity downwards mg. Surface is offering a normal reaction with response to the gravity which is n, and there is a frictional force which is in this direction. So I have just indicated a random direction which is the towards the right. Okay. Now what is the magnitude of this friction, right? So it is experimentally proved that this magnitude of frictional force is proportional to the normal reaction. So frictional force offered by a surface is proportional to the normal reaction, right? Now, if you remove this proportionality, you put a constant. So this constant is generally mu, and since it is a kinetic friction, it is mu k and n. So frictional force is given by mu k times normal reaction, and mu k is called as coefficient of kinetic friction. Coefficient of kinetic friction. N is the normal reaction, and F is the force of friction. Right. Now you can understand how do we calculate friction in different problems, and how do we solve the problems by calculating the value of friction when there is a relative motion between two objects, right? Let's understand by an example. So let's say this is an inclined plane, right? At an angle maybe 30 degree. There is a block of mass 5 kg placed here, right? There is a block of mass 5 kg. Now we need to, and maybe this block is getting some force F here. There will be friction in this direction. We need to calculate what is the value of this friction, and mu k is given as 0.4. Kinetic friction constant coefficient is given as 0.4, right? Now if you draw the free body diagram here, you know the normal reaction will be in this direction because surface is an inclined surface. mg will be in this direction. This will get mg sin theta component, and this will get mg cos theta component. So now along axis, if you equate the forces, right? Let's say these are my axes. So let's say along y dash, if I equate the forces, there is no movement in y dash. So normal will be equal to what? Mg cos theta. And I know friction is mu k times normal. So 0.4 into 5 into g into cos 30. This is this much Newton amount of friction is getting generated here by this surface, right? This is how we calculate the kinetic friction and apply in the problems to find different parameters, right? So next type of friction is static friction. So when two bodies are kind of stationary with respect to each other, when they are kind of not slipping over each other, then the force, the frictional force acting on them is static friction. Let's understand by a very simple example, right? Let's say this is a surface, right? This is a surface, and there is a very big, maybe this, let's call this as anything, a big block or almirah. This is almirah, right? This is a very big almirah, and then there is a guy standing here who's trying to push this almirah with some force, right? Now this almirah is in stationary condition. Even if this boy is applying the force of up to his maximum potential, this almirah is always in the stationary position, right? Which basically means that there is some force which is keeping this almirah stationary, right? So let's say the boy is applying force in this direction, right? But there is some force which is balancing that F, right? So let's say that this boy applied 10 Newton. This force should also be 10 Newton so that it gets balanced. If boy is applying 20 Newton, this also should be 20 Newton to get this balance, right? Suppose at a value, let's say at 100 Newton, this boy is about to just move that almirah at 100 Newton. That is the max value of friction which is possible here, and which we call as the max value of static friction, right? Now, one thing is clear here, that the static friction is adjusting itself, right? Static friction has a self-adjusting nature. Static friction has a self-adjusting nature. Like it won't stay at its maximum possible magnitude every time. If if someone is applying a less force, it will stay on that magnitude itself. If force increases, the static friction magnitude will increase. If force goes to the max value of static friction, it also goes to the max value of static friction. After that, this boy will be able to move this almirah, and then kinetic friction will come into effect, right? But we understood that the static friction has a self-adjusting nature. But what is the max value of static friction? Again, so max value of static friction is given by mu s times normal reaction. So mu s is the coefficient of static friction. Right? And always remember that the static friction magnitude at any instant will always be less than or equal to mu s n. Right? Equal to is the max possible value of static friction. Less than is what we discussed, that static friction will always adjust itself. It has a self-adjusting nature with respect to the force or the effect which is being caused on that body, right? So this is what is static friction. And again, like kinetic friction, it is independent of the area, right? It is all dependent only on the nature of the surfaces, and obviously the normal reaction, which is again dependent on that, right? So next topic for us is the direction of static friction, right? So let's say this is a surface, we have block 1, over this we have block 2. Now again, static friction will occur in such a direction that it will cause the system or the body to be stationary, right? So let's say if we are applying a force F on this block B, let's call this as B and this as A, right? And let's say this F is not able to move this system. So this is still in the stationary, right? So at this surface, between surface and B, you can see that the friction force is in the left. So let's ignore B, let's talk about A. So since A is not moving, so resultant force on A is also 0, right? So basically means that there is no external force on A. Only the external force on A is the friction by B on A, which is 0 in this present case, right? Now, let's say if I increase this F by some magnitude and B moves towards the right with A, right? Till some distance maybe, okay. Now, what is the force on A which is moving towards the right? That is the friction force only. So the friction force is now supporting the motion of A, right? Friction force is responsible for movement of A in the right direction, right? Because there is no other external force acting on A. So it is not that friction always opposes the motion of a body, but friction opposes the relative motion of a body with respect to another, right? Friction is actually essential in daily life, right? So vehicles, right, they also move, they also accelerate because of the friction between road and the vehicle, right? If there is a frictionless surface, there is no friction on the surface, they won't be able to accelerate, right? So friction is not something which is our enemy, we say. Friction always opposes the relative motion of a body with respect to other, but it's not that it always opposes the absolute motion as well, right? Now let's solve some numericals to understand what is friction and how do we calculate. So this is the question. The question states that a block slides down with an acceleration of g by 4. Find the kinetic friction coefficient. This is a very simple question. Let's understand. So this is the only things which are given to us. There is nothing extra given to us. So there is a block. The mass is also not given. So let's say the block of mass m is present on this inclined plane, inclined at an angle 30 degree, and it is accelerating with an acceleration g by 4 downwards, and we need to find the kinetic friction coefficient, right? So we know the forces acting on this. One is the mg, which is the gravity. Then the normal reaction, n. Here, mg sine 30. We are just resolving the gravity. This is mg cos 30. And you know, this is a concept of kinetic friction. The block is moving with respect to inclined in this downward direction. So the frictional force will be in the upward direction. So this is F, which is mu times N, mu times normal reaction. Now, if we conserve these equation, right, along this direction, so let's say this is my x and this is my y. So along x direction, if I apply the Newton's second law, which says that net force equal to mass into acceleration, so net force is what? So if I make a free body diagram for this m, this is mg sine 30. This is frictional force, which is mu times n, mu times n, and this is, and the final acceleration is g by 4 in this direction. So net force is mg sine 30 minus mu n equal to mg by 4, right? And you know n is nothing but mg cos 30. So mg sine 30 minus mu mg cos 30 equal to mg by 4. Now we can cancel out m, and we can cancel out g as well. So 1 by 2 minus mu root 3 by 2 equal to 1 by 4. Now you can find what is value of mu here, right? Okay, so let's solve one more problem on this static friction, right? So this is a block system given. There is one block placed over another, which is placed over a frictionless surface. The surface is frictionless. There is a friction between these two blocks. The coefficient is mu. The coefficient of static friction is given by mu. So we need to find what is the maximum force F which is applied on this capital M block so that these blocks move together, right? And why the question is like that? Because if F exceeds some magnitude, there is a chance that M will slip back to the left. So we need to find the max value of F, which we can apply so that these two system goes together. These two blocks goes together with a common acceleration, right? So now let's understand what are the forces acting on these blocks, right? What are the forces acting on these blocks? So if I talk about M, small m, right? And let's say the common acceleration is a naught, right? The common acceleration is a naught, right? So small m, the force on small m, one is the obviously the mg, and let's say another is the normal reaction n1. Let's call this as n1, right? Now this small block is moving right with an acceleration a naught. So what is the force on this small m? So only force on this small m is the frictional force, right? Only force on this small m block is the frictional force, right? So I said the tendency, it has tendency to slide back to the left because we are putting force on the capital M block. So the frictional force will be in the opposing tendency direction. So it has tendency to go towards the left, the friction will be in the right. So it has a frictional force in the right direction. Let's say this is F1. And this same F1 will be in the left for the capital M, Newton's third law. So even here, if I make the capital M also, the capital M block, so for this, F1 will be in this direction, F is in this direction, and it is also moving towards this direction, A naught, right? Now, let's equate, because there is no friction here, this surface is frictionless. So now let's equate the forces, right? So this N1 is coming here as well. And this will get even one more normal reaction because of this. So this is mg if I complete the overall diagram, and there will be one more normal reaction from this surface, right? So this we can ignore because this surface is anyway frictionless, right? So if I talk about small m, right? If I consider small m, so you see the force, there is only one force which is the frictional force, and friction is supporting the motion of small m here. So F1 will be equal to ma naught, Newton's second law. F1 is mu times normal n1 mg, which is equal to ma naught. So a naught is nothing but mu times g. So what is the common acceleration by which both blocks will move? This is mu times g, mu times acceleration due to gravity. Now placing this value in this for capital M, we can easily find what is the value of F. So here F minus F1 is the resultant force, and this is equal to ma naught, right? A naught is the net acceleration. So F minus mu times mg. So friction is again same. Mu times mg, and A naught is mu g. So F is nothing but mu g into m plus m. So this is the max value of force which you can apply on the capital M block so that these two block moves together. If the force exceeds this, then there is a chance that they won't move together and there will be a fallback somewhere, right? So let's solve one more problem on this. Okay, we understood the basics of static friction, kinetic friction, and how to combine the Newton's law of motion coupled with the friction. So more problems we'll solve in the next class. Till then, thanks.